Hello, Internet. Sometimes I get these weird cards like this. And no, this isn't the 3060. This is PNY A4000. I don't know what's wrong with them, but judging by the I/O, OMG, we have rust. So I don't know if the problem is as simple as rust inside of the HDMI port, so therefore they don't post. So we have rust on this MOSFET here. This one's powering the memory. It's not very good. It just looks a lot of corrosion. Were these servers running inside of the aquarium or some sort? Really hard to say. Not a whole lot to look on the back. Maybe a little bit of here and there, but mostly it looks like most of the problem area is gonna come here. So I'm gonna start checking for resistances right away, because I don't even know if it's worth fixing anything in here or not. It could be dead for all I know. So we're gonna check for 12. 12 is okay. 3.3. This one's probably 5. This one's gotta be 1.8 maybe. So nothing beeping. We can probably check the actual value. So 4 or 5K, probably 5 volt. Could be 1.8, I don't know. 1K, so this is probably 1.8. This is likely 12 because it's rising. This is likely PEX because it's all the way there. Yep, 8 ohms. And the memory should be low, 25. So memory looks good. So we got two memory phases, and this one here is 12 coming in to the 6-pin PCI Express connector. Okay, so to rule out some of the non-detect situations, we're going to check the data lines. First and the second. Nothing there. Let's check the two capacitors on the back. Be sure they look the same. Okay. Clock reference, plus minus, and the PEX reset pin should have a reading, and we have a reading. Okay, so at the very least we know that the pin is connected to the chip. Where the chip is located, I have no idea, but we can probably find it by finding any kind of 5-leg chip and start probing its input pins. Not here. I don't think it's gonna be on this side of the board anyway, but could be, who knows. Not here. Not here. There, so it's here, and the input is not short, the output's not short, and it looks like both of the inputs are shorted, so they don't really care. That's basically like a shortcut, so we don't need two inputs. One input coming from the PCI Express will trigger the enable. Okay, who cares? I don't even think the problem is going to be on this end, on this side of the board, because all of that looks like it's just grease from the paste, from the thermal pads that may have actually protected the board from from corrosion. So, but we're gonna look around anyway and see what's going on. Everything here looks kind of okay-ish. Let's check out the area over here. I don't see anything critical. A little bit of rust near the display. So we're gonna get back to that. If we have any problems with any of the display ports, we'll have to look at that area here. So we have no shorts. Let's go and power the board. See what it does. That would be shocking if just scraping things around would bring this card back to life. Okay, so looks like the core is powered, and so is the memory, and we're pulling 1.2 amps. And well, that's great, but do we have voltages like PEX? What the voltage is on the actual memory? 1.26. Okay, do we have PEX? Yes. And we have core. Okay. 12 here. That's 12. That's 5. And that's 1.8. Okay, good. Everything's looking good. So, no HDMI ports. All of these are display ports, which is wonderful. So let's try this display port. Actually, no. I'm not going to try this display. Well, why not? Let's try. I wanted to see if I could get a reading off of that chip. See if we get a enable. So I'm going to power it on. See if we have an enable. Yes, we have enable. So the chip is working. Let's see if the thing posts. And the duck on the screen went away. And the card posted. Perfect. Okay. So with that there, the card is now fixed. Now let's try this port. So my guessing, yeah, this port is only if you wiggle it around. Okay, so my guess is, I don't know how customer determined this to be a non-functioning GPU, but as you can tell, it does not work from this port. So I'm thinking that maybe he just kind of tried to get an image and it wouldn't post, and it doesn't even react to this port here. This port is completely busted. And so is this port. Yeah. Okay. So 3 ports are busted, and I doubt that there's any problem with the circuitry of these ports, but rather rust, corrosion, oxidation, whatever. So let's go ahead and look under a microscope, see if we can confirm that theory, because it felt crunchy going in. So this port here, I know it's hard to see, is kind of okay-ish. This one has a lot of rust buildup. This one's even worse. And this one's a little bit better, but still a little bit of rust. We can just clean all that rust out, and I'm sure every single port will work. So I'm gonna have to throw this thing into an ultrasonic. That's gonna help a lot with breaking away all that rust. Not necessarily remove it, but it'll get it loose, and then I'll go in with the electronics contact cleaner, finish it off, and hopefully that would be it. And my guess is that this card here will have, yeah, the ports in there look exactly the same, so it'll probably have the exact same issue. So I'm going to go ahead and take the other one apart, because it'll probably have to do the same thing anyway. This one looks a lot better, but very similar. Looks a lot better on the inside at the very least. So I'm going to go ahead and check resistance real quick on this guy. Make sure it's worth a try. We might even check the check it for temperature instead. Okay, so good here, good there. Memory is okay. 12 PEX. So my guess, this guy's probably gonna work too. Display port number 1. Ooh, so crusty. Probably nothing. Yeah. Let's try another display port. Yeah, nothing there. Okay. Let's spray some stuff in here. And just go into that port here a couple of times. See if that's gonna give us an image. And if it does, then we're good to go, proceeding with the cleanup process. There we go. It's posting. Okay, perfect. Just a second, you'll see a picture. Okay, there. Okay, so I'm guessing 2 working cards, just just the rust. So gonna have to deal with that. So I'll go throw them in the Sonic, and hopefully take care of all that rust. And I'm kind of hoping that throwing them into the Sonic would create a problem, so that way I can solve the problem or fix it so it does not happen in the future. That's kind of one of the ways to deal with the corroded cards, is to throw it. Once you got it fixed and you think you're all done, throw it into the ultrasonic cleaner, and what you're doing is you're basically speeding up the process of eating away whatever extremely thin layers of either solder or copper that had been corroded. So you're going to speed up that process of eating it away, and eventually creating a problem that you creating the problem, and it just manifests itself a lot sooner than it would have been otherwise. So you're just basically doing yourself a favor to prevent potential return and a warranty repair. And since I do warranty repairs sometimes, and I do not want any of the cars to come back, it's best to take a little bit of time while the car is still here, and do all you can to make sure that it's done right, or at least as best as you can, than to have it come back and deal with the returns with the warranty repairs, because that would suck. So I'll go clean these up and I'll be right back. Okay, the cleaning is done, and the ports look a lot better. This is one of the good ones. There's still corrosion on the surface of the port casing, but the pins there, they held up pretty good. I still see plenty of gold plating on there. A little bit of, I don't know if you can see this, there's a small chunk of corrosion that's still there. We can just pick that off like so. So I'm thinking what I want to do now is I obviously don't want to leave it just the way it is. So just gonna insert what was a tip of the Q-tip, and just kind of work my way around these pins like so. And that Q-tip is saturated with contact cleaner, and usually it does a pretty good job. I mean, it's not the best. I don't know, I haven't really tried that many of them to know which one works best, but this one works okay. So it dries out quickly, so I kind of have to recharge. For a more serious corrosion, you could just simply repeat the same thing, but add a little bit of toothpaste, and toothpaste will basically polish the pins a little bit, so that's always a good thing. So I'm just gonna focus on the top for now, and do all the ports for the top. It doesn't look too bad. I mean, there's a little bit of corrosion, but they do shine a little bit, the pins. So we'll give it a try. We'll see which ports work, which ones not. Hopefully it won't come to, it doesn't look like it's gonna come to replacing the ports. I don't think so, but I don't know. We might have to do a toothbrush polishing, the toothpaste polishing. I don't know. We'll see. Some of these pads look okay, some of these don't. So we'll have to see if this process here is gonna help us or not. I just want a good consistent signal on all of them, and if that's what I'm gonna get, then we're gonna just keep it the way it is. A little more, keep adding the solution, it keeps evaporating. And the last port, we had no issues with this port whatsoever from the very beginning, but we still want to do it a little bit. See if we can get any corrosion out from the casing, and it doesn't look like it. So whatever, I think that looks okay. Let's blow it out. And power it on and see if it posts on all of the ports. And if that's the case, we're just gonna put things back together and call it a fix, which would be amazing. Easy fix, but not necessarily quick one. Takes time to do all that, as you would imagine. So let's try. I'm gonna clean this one here before I start, because it was dirty from the last insertion. Okay, so let's see. Hopefully it works right away. Okay, I think, yep, this one posts. There we go. Clean image. Okay, sometimes you could have it posted, but it'll show you like weird colors and green lines and whatever. So it's just the same, just not cleaned enough. So try some toothpaste on there. Make sure you keep it wet so it kind of polishes it out. So this one posted as well. Waiting for a clean image. There we go. One more. Looks like that one works as well. There we have it. And the last port that was actually okay from the beginning should work no problems. There we go. There we go. Perfect. So this one's done. Now let's go and repeat the same process with the other guy. Boot the card and see if it posts on all of the ports. And finally conclude with the repair. So let's go ahead and try. See if we get a picture right away on this one here. Alright, so this one doesn't want to boot anymore, which is great. So looks like whatever Ultrasonic did had finally done something to this thing so that it killed it completely. Let's see, are we missing any voltages? That's why I wanted to run it in the Sonic, so that whatever problem there may be, they will manifest themselves now or never, or much later. So let's see, do we have, I want to see if we have PEX. So we got PEX, so we got that, so we don't have memory. Okay, so no memory. We're not short on memory, are we? No, we're not. Okay, we're good. So no memory, which means we might have a problem here on the back. So let's go ahead and take a look over there. There could be some resistors here that got corroded and finally got sort of washed out. So we're gonna have to figure out what's going on. Now let's go figure out. This isn't exact board view. This is some random 3060 I found online. So we're just gonna be poking around this chip here. I'm guessing this is the one that's driving. Okay, enable. Let's see if we have enable pin. That's the one that's driving memory. So let's have a look. And check for the enable pin. Pin number 3. So the pin number 3 that would be enable, as you can see, has nothing. And it's not pulling low, it's just not there. Now where does that come from? Oh, that's a good question. If we were to look, let's see, if we were to look at that board view here, it looks like it could be capacitor ground, resistor from 1.8. Okay, so there's a pull-up resistor and a 0 ohm somewhere. So most likely this resistor here. But if we look at our card, that resistor would have been here. Do we have 1.8 there? Yes, but that resistor is not there. So where else could that possibly be? Let's have a look at the net. So that 10K 0 ohm. So it's this 0 ohm resistor that would go down below. Let's have a look. Let's have a look at the let's check if this resistor is 0 ohm. And we're not going to check the resistor, we're going to check the connections before and after the trace. Switch to beeper mode, and we're not reading anything. So we're reading from here to here, from here to there, but this pad here reads. But if you read from here to here, we read nothing. Therefore, this resistor, can we even measure it? 232 some weird kilo ohms. That's not normal. So we want it to be 0 ohm because we're you know what, before I do this, let's look over at the working board. See, that resistor doesn't even look that bad. Let's make sure that it is actually 0 ohm. And it is, right there. See? So the resistor actually turned from a jumper into a bugger. So let's get rid of that resistor. There we go. Just a bad resistor. That's all it is. And we're going to bring in a 0 ohm. If something happens and there's some kind of a short, that resistor might save the board, whereas wire most likely will not, because chances are the resistor will blow long before any kind of damage is inflicted onto the board. So we have that soldered down. So actually we did have to do a repair after all, huh? That's incredible. I'm only hoping that none of the feedback components are bad. Let's go and power the board and see if we're actually gonna get the memory voltage now. Hopefully it's not gonna be more than it's supposed to be. 1.3. And the card is posting. So we're gonna go ahead and check every single port, turn off the multimeter, make sure that every port is working, no green lines, nothing. Then we'll put it together and do some benchmarks or tests basically. So this one is nice and clean. Yep, there we go. So eventually those flickering images that you see on the screen when the display changes and whatnot, these are gonna go away because I am planning on switching to 4K, and unfortunately to get the 4K I have to go see, the thing is, I'm capturing all of my stuff using a 4 or basically quad capture card. So the card that I'm using right now, I think it's Magwell or something like that, and it allows you to change the images that you see when the image is lost or something like that. You know, that's why you get all these images every time when the display changes. But in order for me to switch to 4K and have 4 ports, because otherwise I would have to get at least 2 of the 4K Magwells, which is going to cost me a lot of money. It's cheaper to just buy a Decklink Quad by Blackmagic. So that's what I bought. It's like, it's not cheap, but it's cheaper. And on top of that, so they don't have the option to customize the missing signal stuff. And hopefully everything works out well, because just switching to a 4K monitor was a nightmare. I had to swap my HDMI splitters, HDMI switches. Half of my cables had to get thrown away because they're listed as 4K, but they're not. I had so much trouble with cables. It's ridiculous. I'm at a point of spending probably over $500 right now to get a HDMI tester analyzer, so that way I can stop wasting money on the equipment. Knowing that, because you know, I've wasted a lot. Good thing I have Amazon Prime, so that way I can return stuff and the shipping is free. And so I was able to actually test quite a few of the splitters and switches and, you know, cables and whatnot. But it's just annoying, you know. Just so much time. It's you try, you get a new device like a switch or a splitter, and then you mess with it, it seems to work at first, but then eventually it starts to fail, and you're thinking, well, this HDMI splitter is garbage. And so you end up returning it. Then eventually you're gonna go through, you know, several of these switches and splitters, and then you eventually stumble on a bad cable. And then so you're like, okay, cable is bad, so you're gonna start you start burning money in cables, trying to figure out which cable is good. You know, and then you find this one cable that's good. Okay, that's number 1, number 2. And then you're like, okay, so that's the brand I'm going to be buying from now on. And you buy a whole bunch of cables. And then for whatever reason, they start giving you problems. It's ridiculous. So I've had a good brand cable. I'll show you in just a second. All these braided cables, I don't know, I don't like them. So this here, like this cable here, for example, it says 8K. Holy cow. And it's got this red thing here, and pins are not gold plated, so that may have been the issue. And it's all braided. When the cable is braided, it's usually really hard. So no, I don't like it. Then see if you can lose a signal. You don't. Okay. Then I had this cable here. I can't even pull it out. There. This cable here, another 8K HDMI. This one's cable Corrosion or something. This one has gold-plated fingers on there, so that's good. I think this is a good cable. But again, it's very stiff because of all that braid stuff. And then you run into a problem with the distance, because it's either your... Man, this thing is nasty. Either your HDMI splitter or switch cannot provide enough single strength for, like, 10 feet cable or whatever, which I needed. You're just running into all sorts of issues with 4K. With 1080p, it's a lot easier. But when it comes to 4K, there's just a lot of issues with stability. Then you're running into a problem with the testing software. Testing software doesn't like 4K monitors. At least the ones that I'm using, they just don't support lower resolutions like 600, 680 by 480 or whatever, something like that. I don't remember what it was. The older resolutions. Because those software, they sometimes run on the older resolutions, and things just don't really work very well. So yeah, switching to 4K is not easy. Not to mention all of the data storage that I need to store all of the recordings and whatnot. 1080p, just 3-4 gigabytes. Well, maybe up to 5 gigabytes per video. Just depends. And there we have it. 2 cards fixed. That counts as a good day. I'm going to go ahead and test them all out, make sure that they work properly, and thank you for your time watching this stuff. Hopefully learning something. And don't forget to like and subscribe, and we'll continue on fixing something else. Goodbye.